Bonjour. That's to the extent that my French is. It's my pleasure to be here today to share with you what we are doing at Microsoft Research. As indicated, my name is Kuansan Wang. I'm actually from Microsoft Research. Microsoft Research is actually a very special organization in the company Microsoft, in the sense that we are created as a research organization. So this year, we are celebrating the 25th anniversary. 25th anniversary. So we were just we are created when Microsoft was 16. And it was created by Bill Gates at that time. The PC is taking off in 1991, and Bill Gates realized that we need to have a research arms to create a technology, original technology from Microsoft, not just to take from outside. And so he founded this organization with the mission to function like a research institution. So if you have an opportunity to visit us, you will find us to function more like a computer science department rather than a product group. We are given a lot of academic freedom. So we are actually going out, function like a professors, writing papers. We do have interns coming in to work on a research project with us. And more, though, what I'm going to share with you today is we found out that research work and the products, the boundary is becoming less and less clear, especially with the advancement of cloud computing and artificial intelligence. And so starting the year before, we researchers in Microsoft Research are actually given opportunity to put our technology and make it as a product directly in the cloud. And that's what I'm going to share with you today. So it's very exciting that for the first time, we're not just talking to researchers or academics. We're actually talking directly to developers and end users. And I'm here to share with you our journey. So this is our second year. Microsoft mission, when we were created 25 years ago, has always been this. We wanted to enable PC to be able to speak and listen, to be able to read and write, to be able to see and draw, and to be able to sense and feel. And so these, if you look at this is basically, over the years, you probably hear some terms like natural user interface or the perceptual user interface, so on and so forth. But it is the terminology today is called artificial intelligence. And this is what we have been doing for 25 years. I was very lucky to join Microsoft in very early, starting as a speech recognition researcher and recently as a natural language processing researcher working on search. And so this is actually what I'm going to share with you today in terms of what we have. So why did Bill Gates feel that it is possible to do? 25 years ago, it was probably not as obvious. But today, I hope that I can convince you that it is actually more realistic than any time. So if you think about what intelligence is, especially in terms of cognition, what is the definition of cognition? Cognition is the mental process of acquiring knowledge and understanding. And so what does it take? It takes memory, it takes computation, it takes knowledge, endurance. Does anyone in this room still question that machine and human, which one is better? In terms of memory, machine won't forget what is learned, right? And whatever it sees, it just remember, and its capacity is huge. Our human memory, there's a famous psychology discovery called short-term memory. And the famous textbook is called The Magic Number of 7, plus and minus 2. So in our short-term memory, we only can remember at most 9 things. Machine doesn't have this limitation. In terms of computation, You probably heard about the computer already beats human in playing chess 20 years ago, and recently it just beats human in Go. And is that intelligence? Well, but if you just look at what it does, it's basically just computation. First, it memorizes a lot of winning situation, and then when it plays, it just compute all possibilities. So is that intelligence? That's definitely not how we humans would play the Go, machine of Go. But for machine, there's no reason it has to work like humans. So if you know the history of AI, AI has been in the news for several times. This is actually the third time. We have two previous what we call AI winters. That AI is all very high, and then it actually did not meet the expectation. This time, however, things feel a little bit different. I can share with you why it is different. First, for the previous two AIs, what scientists were looking for is to explain what intelligence is. So they try to make a machine to mimic a human. This time, though, we realize that that's not the right approach. There's no reason that machine has to work the same way as human. So we basically forego that limitation and let machine do it itself. And so we throw a lot of data at it. Obviously, that's not how we human process natural language, but it turns out the machine can find a way on its own. And so this is actually quite amazing. Not to mention the endurance. We as human, we have to take time, we have to take break, we have to sleep. There's no such limitation for machines. So a lot of tasks can be achieved by brute force. And this is what basically this wave of AI is doing. We just brute force feeding machine with electricity, and that's it, and let it run 24 by 7, 7 days a week. So over the 25 years, Microsoft Research has accumulated a lot of assets in the area that we just talked about. And so starting last year, we started putting our technology in the form of cloud APIs on the web and for everyone to use. So if your startup is doing anything that is related to do cognitive processing, this is the API that we encourage you to take a look. You can see the category roughly is broken into the category that our mission. The first one is about computer vision. It's having the machine to read and understand the images or video. And the other part having to draw is computer graphics. That's not part of this offer. The second one, speech, is the capability for a machine to understand speech and speak to you. And so you can see the recognition and all sorts of synthesis are in that offer. The third one is actually natural language processing. For a lot of documents that were written intended for human to read, now machine can actually read some of them. You probably heard about last year, the Summer Olympic in Rio. A lot of newspapers are actually created. A lot of news briefs are actually written by machine. What they do is they train a lot of tiny little robots to read a little brief, summarize the result, and publish a news article. You probably can tell the difference, right? That's because a lot of news articles, they have the same template. Machine can read the same template, and boom, there it is. So in terms of natural language processing, we have quite a few of them. The fourth category is actually, the speech and language. Currently, we have language constraints. So of course, you have English. For speech, we have 18 language. So French, and Canadian French are included. I just checked. The natural language, though, the column row, currently the focus is English. Sorry, the French is still not there. But I'm going to show you some exception. The fourth one, though, is about semantics and knowledge. That is language independent. It's the way how we conceptualize it's the way that we teach machine to conceptualize the world. so that it can actually accumulate knowledge and actually serve the knowledge back to us. And a lot of these technologies, originally, Microsoft Research is actually working with the search engine to test it out in a large scale. So over the years, we actually have a lot of technology going through the search engine. So in terms of search-related technology, the Bing is the API, has the API. And like I say, these are all available as a cloud API, and that for you to incorporate into your possibility. So today, I'm just going to take you through a few examples of them, and give you some feel about what it has. The first one is the computer vision API. Last year when we launched, you probably got bombarded by the social media about how old everybody is putting their photo, and the computer will actually guess the gender and age of the photo. This is actually part of the computer vision API. What it does is that you can upload a photo, an image, and the API would actually analyze the image for you. It tells you whether this is a portrait of a person or it's actually a scenery photo, and what kind of a color scheme it has. That's one method call. You can a lot of media get that. And so one of the practical applications for this is you can use image to search image. Because that once you upload image, you extract the features through this API and then use those things to query the system what other images are similar. The second one is the OCR. So a lot of time you take a photo, there's some text of it. This API can actually put the pixels together and reconstruct the text out of it. One of the practical applications would be taking your photo, like I come here, I don't read French a lot. I can actually take the photo and read the text and do the translation, translate it into English. And so that's actually also become one of the very popular things that you see going to a Chinese restaurants. You don't read Chinese menu, it's okay. There's a way to deal with it. One of the cute API is Smart Photo. It tries to understand what are the important things in the photo and if you need to create a thumbnail, you will zoom into the important part of the image and create a thumbnail for you. So these are just give you a feel of what computer vision is. So in a sense, the computer is helping us to understand a lot of photos. And a special case for the computer vision is involving people. So there is a special face API over there. What it can do is dealing with a lot of human faces. The how old was actually one of these applications. So the first one is that it will try to identify are there any faces in the image. And once it identifies face, it will try to guess what the person, the gender of the person and the age. And in some cases, it will also tell you what the person probably is feeling. I'll give you more example later. And then another possibility is face typical application in the you see in the movie about FBI tracking a criminal. That's actually the face recognition. So you can first identify a lot of faces. They segregate them into groups, into grouping. And then once you give a photo, you will try to identify which one is the closest one for you. The emotion API is a special case for the face. Once it identifies face, in addition to gender and age, you can also tell what it feels, what it thinks, the emotion, the people on the photo are expressing. And this is done by looking at a lot of images on the internet. So this is not hiring human to label the photo. This is done by going out to internet, crawl all the images, and a lot of times those images comes with the text surrounding them. And so you analyze the the sentiments carried out the text and then associated with the image. So this can be done in a very, very large scale. So in a way, how do humans actually recognize the facial expressions? By practice. What we are doing here is the same to the machine. We are training the machine to read a lot of images and take the cues automatically. So it's not 100%, but nevertheless, it's a lot of fun. And so one of the applications that I know of is for some advertisement company. They put this and then put a lot of test subjects in front of them, and they present them different kind of a marketing pitches, and use this emotion to detect whether which one is more effective or not. And obviously, in addition to still images, we can deal with vision. We can deal with video as well. And the idea is very similar. Video is composed of frames, so you take each frame as a still image, but stitch them together. The difference here is that when you deal with videos, they have actually temporal correlation. So adjacent frames are typically very similar together. So by utilizing the temporal relationships between adjacent frames, we can actually do a lot of processing better. So some of the application is actually a stabilized image. So if you have some camera in the sports and the video is jumping up and down a lot, jerks a lot, this one can actually help you to stabilize. Similarly, so there was about computer vision. For speech, there's a lot of free API that you can use as well. In addition to speech recognition, you can also do synthesis. So it has quite a few voices built in. The speech recognition API, for example, like today, it can be recorded and then subtitled into text. Again, this is done. Used to be very expensive process. We wait for government agency to release large data sets, but nowadays it's actually quite straightforward to do. There are a lot of videos on the internet, and a lot of videos actually come with closed captions. So you just take the audio track, takes the text track, and that's the training example, and let the machine to go through it. And that's how amazingly the speech recognition had made progress over the past 5 years. It's because a lot of labels, a lot of training data becomes useful. A lot of times, there are actually multiple transcription. It's an English subtitle, there's French subtitle, there's English track, there's a French track. And so we actually are able to train all of them. And so one of the related services, APIs out there is translation service. Sometimes, I don't know if you try the translation, sometimes it looks funny, sometimes it looks weird, look very correct. And that's because all the materials are actually coming from the internet. If some of the translation, there are people playing with the system, it can give you some very bad results. But again, the thing I would like to highlight here is this is this is done just by training the machine to get a lot of data from the internet, and so it can be done very quickly. It's similar to expose the machine 24 hours a day to a lot of training example. So it's, in a sense, not a surprise that with the perfect memories the machine has, it can memorize a lot of things. The performance is getting way better than just a few years ago. In terms of a text, this is the same example. There are more and more text out there. So we currently, for example, how big is the internet? Do you know? It actually have trillions of pages. We just publish a lot. especially with the social media, we're just getting more and more. And so guess what happened? You just ask the machine to read all this. What happened? The machine can actually memorize a lot of things and try to make sense out of it. So this is the web language model. That's a researcher speak, but the idea is that you just basically expose the machine to see, okay, there's a lot of text. Give me a pattern that you frequently see. And typically those patterns are frequently vocabulary or phrases that we use a lot. Especially if you are dealing with Donald Trump's tweets, he doesn't use much vocabulary, so it's very easy to do. So this web API is basically this. It's trying to count how many phrases are actually seen together a lot, and so those are actually popular phrases. By doing this, the machine can actually break a sentence into phrases much better than human a lot of times. And you probably see a lot of search engines that try to predict what you use. So in English, we have a phrase that you understand me so well that you can complete my sentence. In a sense, this is what machine is trying to understand you by trying to complete your sentence to see if it is correct. So you see the example of auto-completion. That's actually embodiment of trying to see how the machine can try to understand you by matching you to the existing patterns. We started out to train the machine to read English, but it so happened that there are a lot of articles, that documents there, they are multilingual. So accidentally, the machine can speak a lot of language. So one of the examples is this. So if you this is something like a hashtag. A lot of hashtag, you put words together. So we have a little demo here to ask the machine to do word breaking, to break the tag. And very surprisingly, we found out that we thought we are training the machine just doing it for English. But we didn't realize that actually the machine, by reading a lot of things on internet, and the multilingual comes for free. So this one, it's actually 3 languages together. Life is beautiful, I think, and in French, in Chinese, in English. Look at what a machine can do, right? It just go out, read all sorts of things out there, and accidentally it got exposed to all sorts of things, totally beyond our expectations. So originally we have an API called language ID, language identification. It turns out that we probably don't need it a lot of time. We just train the machine to be multilingual, like a lot of European as well. So I want to spend more time tell you the more advanced part in the knowledge category. So what I've been taking through is computer vision, speech recognition, and natural language processing. And all this are sharing the same patterns. We just let the machine loose to go out there, gather material from the internet, and let it churn by itself. But a lot of time, it seems to learn something interesting, but a lot of times if we want them to serve us, human, it has to learn how it has to communicate with us through the way we conceptualize the world. And so the knowledge category is actually that part of the services in terms of what we computer scientists call knowledge representation. That is the bridge between human and machine communication. One of the example is what we call entity linking service. Entity is a terminology. It basically means that it's a unit of carrying meaning. It can be people, it can be location, it can be organizations or sorts of things, date and time, all that stuff. Those are the basic elements in which we carry meaning. So entity linking means that you read a text and identify what is being said, and how are these objects, entities, are related to each other. If you use the Edge browser, Microsoft's Edge browser, or on the Android, you use something we call Bing Snapshot. You probably already see it in action. What it does is that whenever you load up a web page, there's a little robot behind the scene try to analyze the text, and it will identify the key entities in the paragraph, and secretly do a information retrieval on this. So when you are highlighted a particular person, for example, or location, it can quickly tell you what it is. And a lot of time the name, so in this example, it's telling you who this Peter Beal is. He's a Berkeley professor, so on and so forth. A lot of time the name is actually very ambiguous. So what it has to do is it has to read the paragraph to look at the context, the paragraph, and disambiguate which one is being talked about, especially for a common name like John Smith. You actually have to read the context to know which one is talking about. So this is what the entity linking is. A lot of and this is actually the foundation of machine reads the document intended of a human and try to understand what is being said. All right, so this is actually a building technology, and if you have a lot of them, you can actually put a lot of things together and make the reading even better. And this is not different from how we actually teach our kids to learn the language just by asking it to learn a lot. And the machine, the best way to make the machine to learn better is to help the machine to organize. And that's what we call the knowledge exploration service. So basically, you go out there to read a lot of read a lot of context, understand about entities and how they relate to each other. And they can actually this service basically what it does is creating a knowledge base for you, and basically tells you that I read about this entity in this document, that document, this paragraph of that document, and so on and so forth. So you can actually utilize all this and to create a knowledge about a particular entity and utilize those knowledge to help him to read better. This is actually, and what it can do is it can also rank the importance about things. Michael Jordan typically refers to a basketball player, but for machine learning person, you also know there's a famous professor called Michael Jordan. And so how do you disambiguate them as these two is based on in what different contexts they are mentioned. And these are basically the knowledge exploration service is actually a tool for you to organize things. I'm going to give you an example about how I'm a researcher. So we have to read a lot of scientific papers to keep ourselves up to date. And the research community has become too productive. We are actually writing 1.2 million papers a month. Who has a lot of time to read 1.2 million papers a lot, right? A month, right? And so, but machine can. Machine has no problem to read all that and actually remember what is being taught. Last month is this protein causing this cancer. Next month is a new discovery. It can actually memorize all. So this is actually a service for ourselves. We set the machine out to read all the academic publications and use the entity linking service to take the entities and store them into a knowledge graph. And so one of the example is once you create this, you can actually analyze what relationships exist among all the academic community. In this case, it's showing me who is actually working with whom on what subjects from other material. And what is done basically is this. So it's utilizing putting the two services in the knowledge category together One is called entity linking. So we actually dispatch the entity linking service to read, to detect, to read all the documents on the internet and extract the entity, academic entities that we're interested in, and then we put it into the knowledge exploration service, CAS, together to form a knowledge graph. And this knowledge graph is organized as a API, and then so it can then be utilized to further help the entity linking to understand more and more. So the more it reads, the more it gets better. It can understand more. There is something called language model. This knowledge exploration service, it's like a knowledge base. You can choose what language you want to interact. You can to get information out of it. You can use natural language. Then you have in English, you train an English language model, or if you want to use French, you train a French language model to it. And most of the time, it's just query language, just like what you type into the search engine. Right. So the way we are creating this academic database is like this. So instead of we actually narrow it down to read all the academic papers. So instead of reading just people, location, so on and so forth, we actually train it to read more. It's different scientific concepts. I'm going to show you exactly how many concepts it ended up learning, right? So we have a trend, basically the entity, what we call machine reader, going out there to read 24/7 and constantly to harvest the knowledge base in the graph form that I just showed an example of you. And this is, we make this available. Currently, its size is 1 terabyte. So it takes probably 2 to 3 days with a good internet connection to download. And so the best way to utilize this is not to download it and then figure out how to put it. The best way to use it is directly processing the graph in the cloud. So we put the CAS service on this graph, and out came the academic knowledge API. This is what you see in part of the Cognitive service. With the academic API, I'm going to show you what it looks like and how it works later, but it's just a cloud service. So then we put a HTML front end, so it's more user-friendly to use. And you can actually try it out in this URL. It's called academic.microsoft.com. And let me show you the example how it works later. But before we go there, first let me take you quickly through what this academic graph look like and appreciate its size. Like I said, machine is very good at dealing with the size. And this one is go out and read all the publication. Currently, we have more than 160 million papers, articles, your thesis in the database. And like I said, it's growing rapidly. It's growing exponentially. The growth rate is 0.8% per month, so it translates into 1.3 million papers a month. That's really a lot. Thank God that we have machine to read this for us. So for each publication, we actually identify who are the authors. Currently, we found out it has 110 million authors out there on the internet. What I didn't tell you was this publication on the web. We can actually discover it from yesterday all the way back to 1870s. So it's more than a century. So of course, Einstein are also part of our authors. Same is Barack Obama is also an author, so on and so forth. So there are 110 researchers there. They are coming from 20,000 or so institutions. And the interesting part is that all these papers, just like in the library, you actually wanted to organize them into categories for easy to understand and easy to access. So in the library, there's a taxonomy to organize all the knowledge in the world, all academic knowledge in the world. It's called field of study. And unfortunately, different regions in the world have different convention. In the United States, you have a Library of Congress that decided how you should actually categorize the thing. In Europe, it has a different system. In Asia, Japan, China, they all have different systems. And taxonomy is actually the area that even human cannot agree. So we have a running joke that if you ask 5 annotators in a room to come up with taxonomy, they typically came up with 6. Each one bring their own, and then after fighting, they congregate on something. So this is actually a hard one. In a traditional natural language processor or the AI artificial intelligence people, they spend a lot of time trying to define a taxonomy. This time we decided that let's forego a single one. Just let machine learn one on its own and see what happens. And that's the difference, right? So like I said, we put this graph into the KES API, the Knowledge Exploration Service API. It has 3 methods only, very easy to use, to remember. The first one is interpret. I'm going to give you more example. The idea there is that you convert the query language the user typed into some semantic interpretation. And that interpretation then gets evaluated to get the knowledge out of the system. And the third one, that's called the evaluate method. The third one is actually an analytic to calculate a histogram. So let me give you an example. So if you go to the Microsoft Academic, typically you'll see a query box, just like a search engine. It's functioning like a semantic search engine. And as every character you type, it's actually trying to guess what you mean. And the difference, this one and to the typical one, is that it's not lexical based. So it's not trying to just complete your query. It's actually trying to understand what you want it to do. So for this example, if you type MIC, as you type MIC, it will actually can be completed with things like Microsoft, Michigan State University. These are actually prefix. But if you look at the second one, it also completes as University of Michigan. Why is that? Because it's trying to infer that you probably wanted to type Michigan University, but the official way of Michigan University is actually U of Michigan. So how this interface can be done through the API? Well, it's basically the interpret methods that we just talked about. Every keystroke, you can actually take whatever you see in the query box, send it to the service, and then this is what you get in return. So if this example is that you type in the MIC, it gives you all sorts of a possible interpretation. The first one is, well, I guess you wanted to type Microsoft, so it completes as a Microsoft for you. And then, by the way, Microsoft actually corresponds to the institution affiliation. The second one, oh wow, what happened? There is something missing in here. So I apologize for this, but the second one actually say, well, when you type MIC, it can also be completed to Michigan University, and the interpretation is University of Michigan. So it basically this is how this interface is done through this API. So let's say you select on the first query completion, and this is the search result you will see. Again, the search query is Microsoft. But if you look at the search result, it's very different from the regular search today, in the sense that it's not just matching the keywords. If you type in the Microsoft to any search engine, you're probably getting the results as has Microsoft in the title, as a keyword in the title or abstracts. But here, the intent is you actually want to get the papers from someone from Microsoft. And so it gets all the paper, all the publications based on this intent. And how is this done? Well, this is done is actually going through the knowledge. So you send a query to the knowledge service and tell the knowledge, give me the information back where the Microsoft is actually an affiliation, not just a keyword. And so this can be done through this API using this API call. And so this is how you get the result back. The expression is you want an affiliation as Microsoft, and what you want get back is the title of the paper and all the venue of the publication and so on and so forth. And so this is how it is done. So we open this API for anyone to create a search engine on us. We don't feel that we get the best UI in the world, but we actually want to encourage anyone to create a best way of visualizing this in any form, maybe even HoloLens or any other medium as well. And on the site, you also see that it's not just it's not just serving up the papers, publications. It also gives you additional entities that is related to that. And in the process of retrieving the papers, it can also tell you what are the famous institutions related to the material you are looking for, or who are the famous authors, so on and so forth. So in a way, it tells you university ranking in different subjects. So how can this be done? This is, in this example, it's actually a more advanced query. You can actually ask for the particular area, like a machine learning, after year 200, in the past 5 years. Because everything is indexed, is organized in a particular way. For machine, it takes a few seconds. But for human, it actually takes a long time to organize them. So here, let me demonstrate how you can actually calculate this. And that's the, wow, it looks awful on this screen. That's the third method called calculate histogram. Is for you ask for a particular thing, it goes through, search all the 160 million publications, and find the information relevant, aggregate them, and actually rank them, compute them, and rank them together to get this, right? So again, we put on we put a example out there. The academic API out there is just to demonstrate how CAS, the knowledge exploration service, can be used. The idea there is that we want to encourage you to create your own thing based on this very raw material. It's not just papers. We researchers just not only just read papers. Once we create this, we say, hey, if we ask the machine to read news, what would happen? It turns out that it also reads news fine. So if you go to the home, the entry page of this system, you'll find in the middle column, it actually discovers news. It's actually related news about academic. This is yesterday's news when I prepared the slides. And you can actually select what fields you want to follow, and the machine will read all sorts of news and aggregate them together. In the meantime, it also reads the related conferences, related events that do the particular interest. Again, it's all coming from internet. We just set the machine loose, and it did a lot of things for us. So coming back to what I've been quickly taking you through is something called cognitive API. The idea here is by utilizing what machine is good in memorizing, in computing, in organizing, it can do a lot of things that it will take us human a lot of time to do. And so we recognize the utility of this, and so put it out as the API for everyone to use. It doesn't have to run on Windows. This is a cloud API, so you can actually access it from everywhere. Again, it has all sorts of computer vision stuff. It helps you to process photos, still images, videos. It also helps you to process speech audio, and other audio. It reads documents, and it helps you to organize what it reads for you. Please take a look and tell us what else do you need, and let's work from there. So for the remainder of time, I'll be happy to take questions, and thank you for your attention.
Are there code limits on the API?
There is code limit, yes. And so if there's a free tier, so if you are just a startup, you're welcome to use free tiers. But you are very successful. We want to share your success with us. Thank you. So there's a typical pricing. It actually tells you. And if you have an interesting application, there's apps. You can tell us what you've done. So you can actually go to application. A lot of companies or startups are actually making real fun thing. I was surprised this morning. I checked. Uber actually put a facial API on it. It looks like they use that as a way to authenticate in their drivers. I don't know how many are using it, but it's a lot of fun. And some of the apps out there are companies that actually doing meeting recording. Somehow they put a messenger bot out there. So when two people are conversing each other, they actually record a session, and then they put it into the search engine, so they can actually retrieve. When did I tell that person about that? Now it's very easy to discover. Sounds a little bit freaky, but hey, you never know.
If I want to do face recognition, how many pictures of me I have to provide?
You mean face recognition,
Yeah.
or face recognition? Oh, you mean person recognition?
For me,
You can try it. It depends. I mean, if you have a popular face, you probably need to do a lot. But if you have a very distinct feature, it doesn't take much.
like 10, 1 million.
Yeah. So in our cases, typically 3 to 5 is a good starting point. We do know that some of the companies, they actually try to utilize that for employee access to their building. It doesn't take much. The same API is actually put into some of the Microsoft machine, Surface, for example. There is a feature on Windows called Windows Hello. You can actually log into your computer through your face. It only takes 1 or 2 images as a starting point. But then it's trying to distinguish you against a small set. It's amazingly that it doesn't take much. Similar to the question, there is something called speaker API. So if you feel that the speech API is not recognizing your speech very well, you can actually train it. And typically the training duration is just a few minutes of speech. It will ask you to read a few paragraphs. Yeah. And like I said, the model is actually trained from what we discover on the internet. So it's not surprising that a lot of the speech we discover are adult voices. and actually more male than female. I don't know why. So it actually works. The speech recognizer out of the box, it works on adult male speech better than adult female. And children is actually a challenge. It's actually a challenge. We don't get a lot of children voices out there, even though you imagine there are a lot of children's book or something. Maybe they didn't put it on internet. There's something called custom recognition API. If you have a way to collect a lot of children voices, you can actually train the speech recognizer to be better at the particular voices you want it to do. Yeah, so out of the box, applying the speech recognizer on kids it's not that great.
Hi, I have just a quick question about the speaker recognition API. So if I'm trying to build something for a specific category of people like doctors or scientists with very specific vocabulary,
Right.
Is there a way to extend the speech recognition API so it can recognize these kind of specific words and how we should go about it?
Right. So the case you're looking for is actually not speech. It's actually language. So the speech recognition actually has two models. One is the language model, like the language one. The other is acoustic model. What we just talked about, that it doesn't work with children's voice well, that's the acoustic part. For your application, when you are using it for doctors, they have a specific vocabulary that's actually in the language model. We do have a way to train for you to collect and the good news is you don't have to collect it as speech. You can collect it as text. And you can train the language model based on text and put it into the speech recognizer, and it will work. Yeah, and so that's the web language model thing. We train the largest language model using the entire web as the corpus. But in your specific, a lot of time it probably doesn't meet your need because it's too broad. So for your case, yes, we speech scientists call it speech recognition grammar, and there's a lot of tools that we can talk about more details. There's actually a W3C standard. So when you have a specific corpus you want to train, the language model can be put into a particular format, and that format is called W3C, speech recognition grammar format. A lot of speech vendors all support the same format.
Thank you very much,
Thank you
for being with us.
Thank you for your attention.
Que la famille.